And today I'm thrilled that we have one of our education docents. So a docent in our case is a volunteer who leads education programs, sometimes for school groups and sometimes for adults and families in the summer months. And Steve leads tours of our salt marsh. And so he's going to share today some of his wisdom with the rest of us on this topic. And we're going to save questions till the end. So if you have them, if you could just hold off till the end and we'll take them then. Take it away, Steve.
All right. Thank you. First of all, I'd like to thank everybody for showing up today. It's always a good start. And as Suzanne mentioned, I'm a docent at the Wells Reserve. I do two programs, actually, Secrets of the Salt Marsh and Life Between the Tides. And I developed this presentation, which is a lot different than the Secrets of the Salt Marsh, because one of the things that I found in doing the Secrets of the Salt Marsh is that, you know, I needed to learn more things about the marshes themselves. And basically what I'm going to call some basic things about the marshes. So with that, I'll probably ask people to mute, and I am going to share my screen. Start the presentation. All right, here goes. Okay, a salt marsh is basically, I'm going to start with a basic definition. It's a coastal wetland, and here in Maine, these coastal wetlands are flooded and emptied twice a day by the tides. Often a salt marsh is very much associated with estuaries, and the marshes themselves basically have no shrubs. They're covered with cordgrass, which we'll be talking about, and another type of grass called black grass. And that coverage of the marsh is better than 85% of the marsh surface as a rule. Most salt marshes here in Maine are greater than 10 acres. And another thing about it is peat, the soil of the salt marshes here in Maine, is about 15 feet thick on average. The marshes themselves are one of the most productive ecosystems that we have on the planet. You know, they provide habitat for birds and nurseries for fish, birds, and plankton. The salt marshes sequester carbon and store it. And when I say sequester, go into it a little bit more. Carbon sequestration is actually the process where the green plants take in carbon dioxide from the air and turn it into a solid form that is then stored in the peat on the ground. The salt marshes themselves also provide a lot of protection for the coast in terms of storm surge and flooding. And basically, a good salt marsh will help to reduce property damage in the areas around it. Okay, some basic facts. We have about 3.8 million acres of salt marsh here in the United States. 3/4 of the marsh, salt marsh in the country, is on the southeastern coast of America. And basically between North Carolina and Florida, there are a million interconnected acres of salt marsh. It is an ecosystem that is very much at risk. And we'll talk about some of those risks later on, but about 80,000 acres of marsh, salt marsh, are lost yearly. It's lost to a number of things. One of them is development, invasive species, and sea level rise. When you have a degraded marsh, like many of our marshes are degraded, we're fortunate here in Maine because they're a lot better shape than other places. But a degraded marsh impacts the adjacent coastal shoreline and the habitats. You know, coastal shorelines, the marine life, habitats for marine life and plankton and larvae, etc. Also, the life of birds, you know, bird habitats very important. Salt marshes are important bird habitat. And again, the storm protection is degraded. The salt marshes themselves, by the fact that they are able to capture waves and absorb water, they reduce the energy of the waves, and they absorb some of the excess water that might come in and flood the land itself. The marsh itself is divided into, in practical purposes, is divided into two areas. You have the high marsh and the low marsh. Basically, the low marsh is anything between the mean high water line and basically the mean low water mark. So low marsh goes from mean high water, and it actually can sometimes go and be under the water. The water in the low marsh is shallow, it's warm, it's very silty, and it's salty. It's often submerged. In terms of the high marsh, it is the tidal zone above the mean high water mark. And in those areas, you'll have infrequent flooding. And sometimes the flooding might take place and only be like an hour a day. And this is where salt marsh hay comes from. Peat is the salt marsh soil. It's basically mineral particles and organic matter held together by roots and fibers. You know, so basically you have minerals and decaying plants held together by the roots of the salt marsh plants. Okay. One of the things about peat and why it is like an effective storm buffer is that peat itself is mostly pore space, and peat will often have up to 75 to 95% of it being pore space. And what fills those pores but water? Okay. One of the there's actually three major, I'll say four major types of vegetation that we have on salt marshes here. And one of those is an invasive, but we'll get to that. Down in the low marsh, you have smooth cordgrass, which grows about 3.5 to 5 feet tall. The blades of grass themselves will be up to 2 feet long. One of the things about this cordgrass is that being that it's in the water, it tends to trap sediment and it helps to build the marsh. The cordgrass is like the first line of defense, and the roots and stuff help control erosion and protect the marsh. The only plants that grow there are halophytes, salt lovers. And basically you have this cordgrass, and there are some algae that will live in that area. And cordgrass itself is native on the Atlantic coast. And back in the 70s, they planted some on the Pacific, in the Pacific Northwest, to help control erosion. And it's a very successful invasive over in the Pacific Northwest. And if you look at this picture, whoops, excuse me. If you look at here to the left, this is some of that is the cordgrass. And you'll see that down at the bottom here, it's kind of dark and quite wet. And over to the right, there's a picture that shows the roots and the rhizomes that the cordgrass anchors itself and holds the peat together. Salt marsh hay grows in the high marsh, and it only grows 1 foot or 2 tall. It builds and protects the marsh. You know, even in the winter, the layer of grass, of dead grass on the marsh helps to protect it from the storms. Salt marsh hay is native to the Atlantic coast, and historically, it's been a very valuable resource in terms of hay that settlers use for animal fodder, bedding, etc. And it's actually still used today. Another type of vegetation that's under salt marsh is black grass, or the salt marsh rush. I believe that there's some of this at the Webb-Hannet estuary in Wells. This also grows at the high tide mark, and it has stems 10 to 30 inches tall. And you can see it kind of, just seems kind of delicate compared to some of the other grasses that we've seen. And it could be that you don't see that much of it. The grass species in the marsh tend to grow in bands. In the lower marsh, you have the cordgrass, and in the higher marsh, you have the salt marsh hay. If you look out on the salt marsh, you'll see that sometimes there's places that are basically brown. There's no more vegetation there. That's a salt marsh pan, and a salt marsh pan will form when there's a storm, something like that. The tide comes high, and the grass itself gets scoured and removed from the surface of the marsh. What's left is a shallow depression that's filled with sediment. A salt marsh pan is basically flooded by spring tides and rain, and they don't drain. So if it fills up from a spring tide and exceptionally high tide, the water will stay there until it evaporates or more gets added to it by the next tide or rain. The pans are important habitat for both fish and birds. And oftentimes, if you are at the marsh, you will see birds headed to this area and waiting there, looking for something to eat. And it's interesting, if you look at this dark material in the bottom, that's blue-green algae. And it's just the same thing that if you look at ocean rocks and you see them and they look really, I'd say they look black, but actually a dark blue, I guess. That is this blue-green algae. It's a misnomer because it really isn't an algae. It's really cyanobacteria. And it's like the salt marshes themselves are very important in terms of producing oxygen. But this blue-green algae here is probably responsible for the Earth's the Earth having oxygen. About a little better than 2 billion years ago, there was something called the Great Oxidation Event, and that's where blue-green algae basically gave us our atmosphere. This is Phragmites, and this is an invasive. And there's good and bad about it, but mostly I think we tend to think of it as being kind of a negative. And if you want to see Phragmites, I'd recommend going on like Route 1 and by Scarborough. And the Route 1 goes right through the marsh, and you'll see a lot of Phragmites there. And in some of the roads off Route 1 in Scarborough, the Phragmites grows right up to the road, like actually crowding the road itself. It's really quite an invasive plant, and very successful at what it does. Phragmites australis is the scientific name, and it's also known as the common reed. And it's probably the most abundant vegetation in the world. The non-native variety is the invasive variety that we talk about here most of the time. It grows in dense monocultures. It grows 5 to 13 feet tall, and I've seen that it can even grow taller, but generally you don't see it much taller than that in this area. It's very tolerant of where it grows. It can tolerate whatever environment that it's in, it seems. It is very effective at spreading. It spreads by using rhizomes from the roots and also by seeds. And these seed heads up here will grow, and they actually can go 12 to as much as 20 inches. And, if you've seen them on the side of the road or in the marsh, they're very fluffy. You can imagine a 12-inch seed head is having an awful lot of seeds in it. One of the things that's a problem is that it alters the vegetation. It's invasive. You have salt marsh hay up in the high marsh. Well, guess what? If Phragmites gets in there, it will crowd out the salt marsh hay. It reduces habitat for birds such as willets and the salt marsh sparrow. You know, they're used to growing in the marsh hay, not in Phragmites. It also causes problems because it's so much taller. I mean, salt marsh hay or smooth cordgrass, you know, you're talking between 1 and maybe 5 feet tall. These things grow 5 to 13 feet tall. A lot more vegetation is produced. Also, a lot more debris. And what happens is that debris falls into the water, and that impacts the larval and juvenile fish that live in the marsh. One of the things about Phragmites is it tends to increase marsh elevation, and actually it will increase it much faster than salt marsh hay or the cordgrass that we normally have and want to grow there. This gives you an example. There are a native and a non-native variety of Phragmites. The Phragmites on the right is the native. And, you know, and I look at these here, it's no wonder that, you know, if you think about the David and Goliath story here, this is a David that's very easily going to lose out because there's just so much more seeds and potential for growing with the non-native variety. Interestingly enough, the non-native and the native Phragmites can hybridize. I'm not sure if that has taken place in this area, but it's a possibility that it can happen. I've got this here, it's Phragmites friend de fro. And you know, and looking at the marsh and stuff, you know, I look at it, and if I see a stand of Phragmites in the marsh, I think, oh, that's an invasive, it's bad. And technically it probably is. But there's also some advantages, you know. One of them is that Phragmites, as I mentioned earlier, are larger plants growing in dense stands. Because of their size and the larger roots and stuff, they have a 25% or greater carbon storage capability than the marsh grasses that are there at this time. You have to weigh that out against the habitat reduction for birds and fish and the impact of biodiversity that the habitat reduction will cause. The dense stands can be a buffer against sea level rise. And so far, they have found that the elevation increases that promoted by Phragmites growth are able to keep up with sea level rise. So this, in a way, it hurts the marsh, but you know, 100 years from now, people might say it's the thing that saved the marshes. Who knows? One of the things I want to mention here too is talk about is salt marsh formation and sea level rise, because they're very much related. Okay, in terms of main salt marsh formation, you know, we have good salt marshes here because we live in a temperate climate, and a temperate climate is anything between the tropics and the Arctics. You know, it's that wide band of the middle latitude. We have a stable sea level, okay, we've had for a few thousand years. You need an area that's protected from waves and currents. And, you know, in the case of like the Wells Reserve and Webb Hannet, barrier beaches were involved in protecting those areas so that salt marshes could form. You need a sediment source, okay? You need sand and particles from somewhere that are going to go in and get captured by the vegetation in the marsh and end up helping to build the marsh up. And you also, it helps to have a wide tidal range with salty conditions, okay? We have 9 to 12 foot tides here in Maine, so it's a reasonable range, and also it's ocean water for the most part. So here I'm going to mention something about sea level. And I want to include this because there are two types of sea level. There's absolute sea level, which measures the total volume of water in the ocean. Basically, it's a point from the center of the earth, they measure up, and that is absolute sea level. The only time that absolute sea level will change is when ice melts or accumulates on land, okay? And the land that it's going to accumulate on or be lost from continental ice sheets or mountain glaciers. We happen to have continental ice sheets at the world at this point in the continent of Antarctica, the island of Greenland, the Baffin Islands, which is north of Canada, and obviously, as I mentioned earlier, the mountain glaciers, okay? That's the only ice that we have on land. Ice that's in water, like the Arctic Ocean, and we say, well, the Arctic Ocean is not covered with ice. Ice in water is basically considered water in water, and it really doesn't change the sea level itself. It has to be from land. Okay, absolute sea level. Then you have the relative sea level. And the relative sea level is the ocean height at a particular location. Okay, it's different throughout the world. Things that influence the relative sea level are water temperature. Water temperature gets higher, water takes up more space. Crustal rebound, that's from the last ice age when glaciers came and pushed down on the Earth's crust. You know, we are still, our crust here in New England is still rebounding from the last ice age. And also ocean currents. You know, we have the Gulf Stream here that comes up north, and the Labrador current that comes south. Well, what happens is the coastal currents, the Gulf Stream as it's flowing up, actually tends to pull water away from the coast of Maine. Okay. 22,000 years ago, Maine was covered by the Laurentide Ice sheet. Then roughly about 18,000 years ago, we started getting serious melting of the ice sheet. It wasn't until about 4,000 years ago that the sea level itself stabilized, okay? This Laurentide ice sheet stopped melting, you know, and basically the ice sheets on Greenland and Antarctica stabilized, okay? Which left us with the world that pretty much we have today. During the time that the glaciers were melting, okay, sea levels, I'm going to just put it this way, they went crazy. And this being the coast of Maine right here, what happened is that as the sea melted, it pushed in, excuse me, as the ice melted, the sea level rose and it went up to 62 miles inland. Okay. There were actually places in Maine where marine fossils, shells of scallop type animals and stuff like that, were found at the elevation of 415 feet. Give you an idea, there was a lot of water came in here. When the ocean came in and flooded all this purple area, it deposited a bluish gray mud, which is the marine clay that we have in Maine today. But during that time that the glaciers were melted, this is the crazy part of it. The relative sea level rose 230 feet above the present, okay? Then it dropped 180 feet below the present relative sea level. There's about 400 some odd feet of sea level change that happened from the last ice age to when the ice started melting until it stabilized about 4,000 years ago. That stabilization about 4,000 years ago is what allowed the salt marshes to form. Okay, so this is actually from the Maine Geological Survey, and it shows the 230 feet where the sea level was, and then when it went down 180 feet below what our current level is. What this chart shows is that about 4,000 or 5,000 years ago, the rapid rising sea level slowed down. And when that sea level stabilized, it allowed barrier beaches to form and salt marshes to be established. Okay, and you know what, I should mention one more thing here too, is that these barrier beaches and some of the sediment that goes into the salt marshes are also a product of the last ice age. And in terms of like the Wells, the salt marsh in the Little River at the Wells Reserve, that was formed from sand from the Great Sanford Fan, which is basically a glacial wash that goes across Kennebunk, Wells, and a few other towns down this way. All right, so this is the projected sea level trends, and this is going from 1980 to about 2100. about 78 years from now. Good grief, seems like forever. But basically, what they're looking at is that they're looking at a sea level rise of about 1.5 feet at the best scenario to about 11 feet at the worst case scenario. The reason that sea level rise threatens salt marshes is because often there's a lack of space for them to move landward. And part of that is because of development, human development. Okay? Unless the salt marsh is able to add elevation by peat and organic matter being pumped into the soil, it will end up being underwater. And we're looking at a 20 to 30% loss of coastal wetlands by the turn of the next century. There are other threats too, and I'm going to touch upon a few of them just following. One of them is erosion and peat collapse, and then the invasive species, and that's both plant and animal. We've talked about the Phragmites, which is a plant invasive species. I'll talk about a few animal ones here too. Peace and plenty. I look at some of these scenes and these like turn of the century or older, and they're just so peaceful. You look at them, you see straddles out there where salt marsh hay has been stored for winter. People are farming. Looks really nice. But these marshes are under threat. And actually, some of the reasons that they're under threat is because of human development and working on the marshes. Some of the stresses that marshes are seeing today, we're having stronger storms. Sea level rise can be a major problem. Invasive species, again, a problem. And there's a lack of sediment. In some places, especially when you have a river or stream that's dammed, oftentimes sediment gets trapped behind those dams, and it basically starves marshes in coastal areas. And actually, this is a big problem in California, the lack of sediment. One of the things that happens is peat collapse. And this has happened relatively locally because of farming practices of the last century or two. If you look at a healthy wetland, you have the vegetation there, and by photosynthesis, it grabs CO2 and stores it down into the soil. Then, if something happens to the marsh, and it could be natural, a storm surge, or fire, It could be something human caused, like, oh, we changed the water flow into the marsh. You might have put in a culvert. You might have put in a road without a culvert. You change the marsh and the water that goes in there. Nutrient loading. You know, you'd hear about, oh, what's the fertilizer that you're putting on your lawn, and where's that ending up? Where's it end up? It ends up in the marsh. Too much nitrogen there. And the other is sea level rise. All these things can promote and hurt the marsh and cause the marsh vegetation to die. Once it dies, you know, what was the peat, which was once a very nice carbon sink, starts losing some of the carbon. Okay, excuse me, the carbon dioxide, and it starts leaving the marsh itself. Some of the reasons that the marsh will lose elevation is because, you might remember, I said that the peat itself has 75 to 95% of the space being pore space. Well, what happens is the pore spaces, there's nothing to hold the pores together. So what basically happens is that all the sediment just collapses on top of each other. Okay, so you lose all the roots and vegetation. The soil itself loses its strength and structural integrity. It compresses, and this is what will cause the marsh elevation to decline. The last thing we want with rising sea level is to see the marsh elevation go down. These are some of the examples of invasive creatures. And this is the purple marsh crab in Wellfleet, Mass. And if you're familiar with the Cape Cod, you know how you have that tail that kind of goes up. If this is the elbow of Cape Cod and this is the end of Cape Cod, Wellfleet is right about the middle, and it's in the Gulf of Maine. The purple marsh crab has gone through, and what it does is it eats the cordgrass. And eventually what it will do is it will leave something like this, you know, I'll call it a muddy mess. Okay. And this shows some of the damage here. And what will happen is, like, this is probably the first round going through, but, you know, as the cordgrass will start to grow, hey, those crabs are going to come back through and see it as tender victuals, and they'll eat it. Eventually, the cordgrass won't grow there. At the Wells Reserve, and actually many places here in Maine, and actually throughout the country, there's green crab damage. And basically the green crab is an invasive from Europe. It came here in the mid-1800s. And you know, it's funny, it was here for probably 100 years and it wasn't a problem. But what happened when rising ocean temperatures started occurring, you know, 30, 40 years ago, it led to a population boom of the green crabs. They like those warmer temperatures. What the green crabs do is they burrow in the peat and they weaken it. Okay. In fact, in some cases, they'll do studies, they'll take a square meter, just a little bigger than a square yard, and there'll be as many as 50 green crab burrows in the peat. Well, you think about it, it's like now the peat looks like Swiss cheese. So I'm exaggerating maybe, but when a storm comes, it's lost a lot of the integrity, and it's easier for a strong storm wave to come through and break off pieces of peat. Another thing about the green crabs is they eat small clams, mussels, and oysters. And in Saco Bay, which is basically the bay that's around Portland, in the last decade, there's been a 90% reduction in the clam harvest. So this is getting to be quite serious. This is a green crab, and they're not this big. They're really the carapace, which is basically from here to here is basically 3.5 inches, or about the size of a, of a fist type of thing. And you can identify a green crab, not because it's green, but because it has five little serrations here. 1, 2, 3, 4, 5. Your native crabs have quite a bit more, and they're more rounded as opposed to, these are kind of sharp looking. Marsh reclamations, one of the things that will help a lot with marsh reclamation, and it's actually being used in some of the southern marshes that have been hurt, are using mussels. Mussels are filter feeders, and what they do is they grab in the water with all the sediment and nutrients in it, and they spit out all the sediment. The mussels themselves can actually build the marsh faster than the grasses that grow there. And they are able, with the mussels involved, they've been able to keep up with sea level rise in some area. But there's a problem with this, and that in states like Georgia, Florida, and the Carolinas, where they've tried, bringing the marshes back, feral hogs will eat the mussels, and they love them. So it's and if we go here, next picture, you'll see feral hogs. They can be quite numerous in different areas. One of the last things I wanted to cover here was the southern Louisiana wetlands. When you hear the bayou, this is what they talk about. Basically, it's a water saturated coastal swamp. In the late 1800s, early 1900s, a lot of logging took place on the land sides of it. And in getting the logs out, much damage was done to the swamp, because back then they looked at it as a swamp, no value to it. Earlier in this century, and to this day, oil exploration and production has basically caused a lot of damage in terms of they have made a lot of channels through the wetlands themselves. One of the other reasons why there's a problem here with the Louisiana wetlands is because they're at the mouth of the Mississippi River. And the Mississippi River itself, around New Orleans in that area, has been put into culverts and rather contained. It's not a naturally flowing river. And when the water hits the culverts, it moves that much faster. Faster water makes the current push further out into the Gulf. So instead of the pushing out a little bit and the water losing energy and dropping sediment in the bayou or the wetlands, it's pushed out further into the Gulf, and it's actually starving the wetlands of sediment, which is needed to keep them going. Here it is right here, showing even, I think, more damage. But to me, it's kind of startling to think that a football field worth of wetlands is lost every 38 minutes in the Louisiana wetlands. And between 1998 and 2009, a period of 11 years, we lost an area the size of Rhode Island. I know Rhode Island's our smallest state, but it's still a lot to lose. So we'll kind of tidy it up here and say, some of the reasons why salt marsh conservation is important. One, it maintains the shorelines. They support the marine ecosystem. And one of the things about this is that the marshes, salt marshes, are home for some part of their life to about 75% of the commercial fish that we go after. So it not only is it important for nature, it's important in terms of economies. The salt marshes provide critical habitat, birds, migrating birds often use salt marshes. Other birds like the salt marsh sparrow basically live in a short band, maybe a few miles wide up along the coast, because they live in salt marshes their entire life. And, they need to have a salt marsh to live in. In fact, some of these, like the salt marsh sparrow, is expected to become extinct within the next 50 years. Extinct in this area. The marshes protect the coastal communities. They grab excess storm energy and help prevent flooding because they can store excess water. And they also provide thriving local economies. Maine, people come to Maine, I think over 1 million a year. It's for the Maine coast. They come to see the marshes and they come to see it looking good. So it's good from an economic standpoint. And I kind of stress that because being a capitalist and caring about nature and stuff, people have to provide livings for themselves, and the marshes help people in the area do that. When it comes to protecting marshes, I have to say, we all have our responsibility. The buck literally stops here. And I think that's a green crab grabbing one. It's a good find for the crab, but unfortunately, I don't think he can go too many places and use it. So anyway, that pretty much ends the end of our presentation here. And if you have any questions, hey, I'm wide open for it.
Thanks so much, Steve. That was so information packed and wonderful. I learned a lot. Let's see. Oh, great. So we have gallery view here. We can see you all. It's a pretty small group, so you can either raise your hand or just unmute yourself and ask your question.
Hi. You had mentioned, Steve, a barrier beach. I know that's probably not. Can you just tell me what that is?
Barrier beach, and a good example would be, and I'm going to use the Wells Reserve as an example. What happened is about 4,000 years ago, 4,000 to 5,000 years ago, glacial sediment came and it was deposited in that area. Okay, when it was deposited in that area, and probably at the time it might have even been above the water. At this point, it's not above the water. There are only remnants of it. But what that beach did is it basically put a pile of sand in front of where the river was hitting the ocean. That basically in that barrier beach, it absorbs the wave energy, and that let the sediment settle in the salt marsh. And we talk about barrier beaches. I think North Carolina, they talk about the barrier islands. And I've been to South Carolina and actually been in one of those barrier islands. Basically, they're there so that we still have them on the coast. And like in North Carolina, they are often threatened by storms. Indeed.
Steve, do mussel farms have the same capabilities of helping marshes and native mussels in the normal habitat?
I will say this is that to my knowledge, there were like the Wells estuary doesn't have mussels in it, but there are marshes that have them, in the Northeast. One of the things that's interesting about mussels, and this was from the Bigelow Lab about a year ago, they came out with an article about it. And what they're doing is they're having kelp farms. Okay, lobstermen are having problems for a number of reasons. It's not just the right whales, but they seem to be adding to it at this point. So lobstermen need to think about, okay, how are they going to make a living? And one of the things is kelp farming. And what they have done is they have taken mussels and they put them like on a string adjacent to the kelp. What it will the mussels will do, well, they tend to lessen the acidity of the ocean, which is good for the kelp, good for the mussels too. And what the term they use is they have like a halo effect, and they make for a better environment around the kelp itself. So that's, you know, there's research being done on mussels and how it's going to affect the coast itself.
Thank you.
I should mention something too, that mussels, especially if they're in a little deeper water, that they would be better for any I think it would be better for any vegetation that's there to put some sediment out for it to grab onto.
You know, Steve, you mentioned this in your presentation, but it's still remarkable to me that during my lifetime, swamps, wetlands, marshes were considered wasteland. And there were locations for garbage dumps, for tossing debris, for throwing out an old tire, for discarding things. And it's been a remarkable change that's happened in the last 50 years, I think, of people's perceptions and values. It hasn't happened completely. As you know, the expression drain the swamps was used politically the last election term. And it was considered to be a good thing to drain the swamps. Well, it shows how far out of date that expression is in that person's mind, because draining the swamps is a bad thing. We ecologists know.
You know, to actually piggyback on that somewhat, in the recent hurricane that hit on the west side of Florida, there were a lot of buildings that were really destroyed. And part of the reason was that they were built in I don't want to call them wetlands, but in low areas where flooding was known to have occurred. And, you know, probably somebody thought a man-made solution is going to solve this. But one of the things about water is that it is very hard to hold water back. You know, it's going to find its level. So, you know, areas that are at risk, you know, like we have like sensitive areas up here, we say don't build on there. There's really some good reasons as to why people shouldn't build there.